So yes, this is here the introductory part, bivariate and multivariate analysis and objectives of multivariate analysis. Now there are three basic types of analysis which we deal in statistics and which are very useful in the study of geography and different aspects of geography. When we study it, then we often try to put the things in quantitative format and we try to analyze them statistically. So let us see which are these: univariate analysis, bivariate analysis and multivariate analysis. Univariate analysis deals with the examination of the distribution of cases on only one variable at a time. For example, let's say temperature values at a specific place or marks obtained by students in a particular test. So you have only one variable over here which is under consideration. Then comes bivariate analysis. Bivariate analysis deals with the examination of two variables simultaneously. For example, the relation between gender and marks of students, or temperature and elevation, and so on. So there are two variables which we will take into consideration. When there are more than two variables, then we refer to that particular analysis as multivariate analysis. Multivariate analysis deals with the examination of more than two variables simultaneously. For example, the relation between gender, race and marks, or temperature, rainfall and elevation. These are just examples. Now the purpose of such analysis, where and how we will be using, or what is basically the purpose of univariate analysis, basically it tries to describe the phenomena. So if you're looking at temperature, then it will try to tell you the characteristics of the temperature of a particular region, how it deviates, but in terms of the normal situation, like we will be dealing with mean, median, mode, and then looking at the deviations, we will be dealing with the skewness, kurtosis, standard deviation, and so on. Bivariate analysis tries to determine the empirical relationship between the two variables. So temperature and rainfall, if these are the two variables that I'm going to take into consideration, how temperature is going to vary with the variation in rainfall. That is what we try to understand in bivariate analysis. Basically, we try to correlate both. Then in multivariate analysis, the purpose is primarily to determine the empirical relationship between or among a number of different variables. Very similar to bivariate analysis, but as I said in the beginning, bivariate will only deal with two variables. In multivariate analysis, there will be number of variables, more than two. So in bivariate analysis, we can take the example of temperature and rainfall and think in terms of how temperature is going to change, maybe increase or decrease with respect to the rainfall amount, which is going to vary. But when I move to the higher level analysis, that is multivariate analysis, I will say that temperature is alone not going to be defined or is not going to change or vary with respect to a single factor, that is rainfall. So there might be a number of different factors which might be attributing to the variations of temperature, and these might be like rainfall or maybe the height or the elevation or distance from the coast and so on and so forth. So that comes to the multivariate analysis. Now we try to differentiate between these two primary variable analysis, that is bivariate analysis and multivariate analysis. As I said in the beginning, bivariate analysis looks into the relationship between two data sets with a pair of observations taken from a single sample or individual. However, each sample is independent. Quantitative variables are usually plotted on a graph in the form of a scatter plot, and bivariate analysis also examines the strength of any correlation. On the other hand, multivariate analysis takes into consideration several variables to see if one or more of them can estimate a certain outcome, where we can see that the predictive variables are independent variables and the outcome is the dependent variable. The variables can be continuous, meaning they can have a range of values, or they can be dictonymous, meaning they represent the answer to a yes or no type of question. Multiple regression analysis is the most common method used in multivariate analysis to find correlations between data sets. Other might include logistic regression and multivariate analysis of variance. So there are a number of multivariate analysis techniques. which are present and which will be used depending upon the purpose of your study or the kind of data that you have collected. Now the objectives of multivariate analysis. First objective is data reduction or simplification. Now this helps data to get simplified as possible without sacrificing valuable information. This will make interpretation very easy. This is the first objective of multivariate analysis, to reduce the data or simplify the data. The second objective is to sort the data or put them in certain type of groups or achieve the grouping. When we have multiple variables, groups of similar objects or variables are created based upon major characteristics. These are multiple variables that are grouped based on their unique features. The third objective is to investigate or the investigation of dependence among variables. Understanding the nature of relationships among variables is of great importance. One has to understand whether the data collected for specific variables are independent or dependent on prediction relationships between variables. Must be determined for the purpose of predicting the values of one or more variables based on observations on the other variables. This determining of relationship between the variables is vital in order to understand the behavior of the variables based on observations and other variable present. And the last objective of multivariate analysis is hypothesis testing. Specific statistical hypotheses formulated in terms of parameters of multivariate populations are tested. This may be done to validate assumptions or to reinforce prior convictions.